In this video, let's go ahead and practice writing and evaluating some numerical expressions together in some different applications. So for questions 1 through 4, what we're going to do here is we're going to go ahead and write a numerical expression to go ahead and represent each of these dimensions. We're going to be talking about rectangles for these 4 questions. Once we define our dimensions, basically the length and the width of each of these rectangles, we're going to go ahead and write and evaluate, which means solve, a numerical expression to determine the area of each of these rectangular shapes. Once we do all that math, we're just going to go ahead and interpret it and write a conclusive statement to say what it represents or what our numbers represent. Alright, so for number 1, we see that Farah has a backyard in the shape of a rectangle. The length is going to be 27 feet. The width is going to be 1/3 the length plus 4 feet. So let's start off with some information that we do know. We know the length here is going to be 27 feet, so let's start with that. I'm going to go ahead and just define a variable and say that the length, or this cursive L, is going to be 27. That's the length. And what about the width? Well, let's go ahead and define the width here. The width is going to be, it says 1/3 of whatever the length is plus 4 more feet. So if we go ahead and write that down here, we can say that the width is going to be 1/3 of whatever the length was. So of in math means we are multiplying. So that's 1/3 of 27 plus 4. Okay, so we need to write an expression to represent the area. Now, keep in mind for rectangles, we have a formula for the area. That is just going to be area is equal to the length multiplied by whatever the width is. So area equals length times width. Okay, so if we know that, and we know the length here is this 27, and we know the width is this expression over here, we can go ahead and write this expression to find the area, where we can say the area is going to be 27, or we can say the area is equal to 27 multiplied by this 1/3 multiplied by 27 plus 4, right? Basically, this right here is the width, this entire thing. All right, so let's go ahead and actually evaluate this a little bit now that we have an expression to represent the area. Let's start with following the order of operations here. So we have the length and the width, but inside this parentheses, we're going to start with multiplication here. All right, so if you go ahead and find out what's 1/3 of 27, then we can go ahead and say, okay, 1/3 multiplied by 27, that's just going to be equal to 27 over 3. And that simplifies down to being equal to 9. So 1/3 of 27 is equal to 9. So if we go ahead and simplify this a little bit here, we're going to take this 27 and let's go ahead and multiply this by the quantity of this 9 plus 4. Again, this 9 plus 4 is telling us what the width is going to be. This 9 plus 4 is going to be 13. So we're going to have 27 multiplied by this 13. Go ahead and put 13 inside parentheses, or you can use a dot for multiplication or a multiplication sign. And then finally, we have to multiply 27 times 13, but at least we know now that the length is 27 and the width is 13. That's essentially what we just found out here. Okay, so if we go ahead and do 27 times 13, let's see what that's going to be. Well, 3 times 7 is 21, carry the 2. 3 times 2 is 6, plus 2 is going to be 8. We'll carry that placeholder here. The 7 is going to come on down, and the 2 is going to go right next to it. Okay, so go ahead and add these. We're going to get, I think, 351 here. This would be our area. All right, so what can we conclude here? We can summarize our answer and say that the area of Farah's backyard is 351 square feet. All right, let's check out number 2. In number 2, Abigail has a piece of paper in the shape of a rectangle. The length is going to be 75 centimeters. So I'm going to go ahead and highlight this as our length. Okay, I'm going to go ahead and write that down. Let's go ahead and identify the dimension. Length is 75 here. And what about the width? Well, for the width, it says that it's going to be 1/5 of the length plus 18 centimeters. So let's go ahead and define this width here. The width here is going to be 1/5 of whatever the length is going to be. Well, we know the length is 75, so it's 1/5 of 75 plus 18. Okay, so if you want to write the area of this rectangle or write an expression here, it's going to be length times width, just like in the last example. It's going to be 75 multiplied by, we have this width, which is 1/5 of the 75 plus 18. So here's our length and here is our width. Let's go ahead and simplify down our expression for the width here. So let's figure out what 1/5 of 75 is. So we go ahead and do that on the side here. 1/5 multiplied by 75 is going to be, let's see, 1 times 75 is 75. 5 times 1 is going to be 5. And if we simplify this, 5 goes into 75 15 times. Okay, so if we go ahead and write an equivalent expression here, we're going to have 75 multiplied by, let's see, this is going to be 15 plus the 18. And if you want to figure out what that width is, we have to go ahead and just add 15 plus 18. Now, 15 plus 18, I believe, is going to be 33. So we really have 75 multiplied by 33. I'm going to use a dot for multiplication here. All right, so finally we know the length and the width is 75 and 33. Well, I guess we already knew the length, but now we know what the width actually is. To find the area here, we're going to have to go to multiply 75 by this 33. So let's go ahead and do that on the side. If you need to pause to do it on your own, go ahead and do so. Let's see, it's 22. Put a placeholder here. That's going to be 15, carry the 1. 21 plus 1 is going to be 22. If you go ahead and add these together, we have a 5, a 7, a 4, and a 2. So we're really looking here at 2,475, I believe. And so what's our conclusion that we can write here? We can say that Abigail's paper has an area of 2,475 square centimeters. Let's check out number 3. For number 3, Jackson has a metal desk in the shape of a rectangle. Surprise, surprise, it's another rectangle. So let's start with the fact that the length here is going to be 60 inches. Let's go ahead and write down that variable. Let's say this cursive L is equal to 60. And then what about the width here? Well, the width is going to be 7/12 of the length plus 21 more inches. So let's go ahead and define that. Say the width here is going to be 7/12 of whatever the length is of its multiplication, just like in the last couple examples, plus 21 more inches on top of that. So what's the expression for the area? Well, as we've said in the past, it's length times width. The length is 60, and the width here is going to be this expression, which is 7/12 times 60 plus 21. All right, so this is the entire length we were given, but the width was a little bit more tricky, but the width is this entire expression right over here. So let's go ahead and start solving this thing and just evaluating it a bit. So first thing we have is 60 multiplied by, and let's go ahead and evaluate the order of operations. Let's start with 7/12 times 60. Now I'm going to do this on the side here, 7/12 multiplied by 60 over 1. Now 7 times 60 is going to be 420. And then 12 times 1 is just going to be 12. Now, turns out 12 goes into 420 evenly. It's going to go in 35 times here, so feel free to do that on the side, or you could also use the ladder method and say 420 and 12, or you could simplify before you multiply. And you can see here that you can divide these both by 6, because 6 times 7 is 42, right? This would be a 2. And then these are both even numbers, so you can divide these both by 2, and we would get 35 and 1. So you can see if you divide top and bottom by 12, you can get 35 over 1, which is just 35. So we can go ahead and say that this would be 35. And hopefully that makes sense, because if you look at the 7 on a clock, out of the 12 numbers on a clock, that's at 35 minutes of the hour. So hopefully that makes sense. 7/12 of 60 minutes is 35 minutes. Let's go ahead and add this 21 onto it afterwards. And we still have to follow the order of operations and evaluate what's inside this grouping symbol. So we're going to have 60 here, which is the length multiplied the width is going to be 56. So let's go ahead and multiply 60 by 56 here to get the area. So if we go ahead on the side here and just do 60 times 56, 6 times nothing is nothing. 6 times 6 is going to be 36. Put a placeholder here. 5 times 0 is 0. 5 times 6 is going to be 30. So we go ahead and add these partial products together. We're going to get 0, 6, 3, 3. So we're really looking here at 3,360. So what does this mean? This means that Jackson's metal desk has an area of 3,360 square inches. Let's check out another one here. In number 4, Xander has a rectangular puzzle in the shape of a rectangle. The length here is going to be 72 centimeters long. So let's go ahead and write that down. The length here is going to be 72. And then what about the width here? Well, for the width, we know it's going to be 5/8 of whatever the length is going to be, minus 17 centimeters here. So for the width, let's go ahead and say it's going to be 5/8 of whatever the length is. So 5/8 times the 72, but it's going to be minus 17 here. It's 17 less than that. So a little curveball, a little difference here. We're going to go ahead and subtract. Now to get the area, it's length times width. We have the length is 72. Let's multiply by the width here. The width is going to be 5/8 multiplied by the 72. But we know it's going to be 17 less than whatever that is. So let's go ahead and write minus 17. Okay, following the order of operations, this should look familiar from the last few examples. Let's go ahead and take that 72. Let's go ahead and multiply that by, let's see, what is 5/8 times 72? Well, I'll do that on the side here. 5/8 multiplied by 72. Let's see, we can go ahead and multiply this out. I think I'm going to say that this is going to be 360. You can cross cancel if you know how to do that. Obviously, you can do it. We could definitely simplify here. So 360 and 8. Go ahead and see what can you divide these both by. I think you can divide them. I think most people might say 2 first, maybe. That's going to be 180 and 4. Maybe people would say 2 again. That would be 90 and 2. And maybe people would say 2 one more time. Maybe not, but hopefully this makes sense. So it turns out 8 times 45 is 360. So 5/8 of 72 is going to be 45. And if you know about cross canceling, you could have just looked at this initially and said you could divide this by 8 and divide this by 8, and you just have 9 times 5 to get 45 also. Okay. Let's go ahead and take away 17 here. Okay. And then let's go ahead and for the next step, so 45 minus 17 is going to be 28. So we know that's going to be the width. So our length is 72 multiplied by the width we know is going to be 28 here. So to figure out this area here, let's go ahead and just multiply out. Let's take the 72 and multiply it by 28, right? So 8 times 2 is going to be 16, carry the 1. 7 times 8 is 56 plus 1 is 57. Let's put a placeholder here. 2 times 2 is 4. Then 2 times 7 is going to be 14. So if we go ahead and add these two partial products together, we got a 6. 7 plus 4 is going to be 11, carry the 1. 1 plus 4 plus 5 is going to be 0, carry the 1. We're looking at a product here of 2016. So what can we go ahead and conclude? We can say that Xander's puzzle has an area of 2016 square centimeters. All right, let's check out numbers 5 through 8. These ones are going to be slightly different. So for each of these, we're also going to be writing a numerical expression to represent the situation, and then we're going to go ahead and evaluate it or solve it to figure out what's going on. So Tyler buys a new computer for $800. He puts down $120, which means that he has $120 right away to spend on it and give them. He also is going to be getting a student discount of $50, which means he doesn't have to pay that. That's going to go towards that $800 right away. Tyler's mother is going to give Tyler half of the balance, so his mom's going to go ahead and pay half of whatever's left as a birthday gift. The question is how much does Tyler still owe for this computer? So let's see here. How can we go ahead and write an expression that represents this? Well, we know the entire computer is $800. Let's start there. We want to find out how much Tyler still owes. So what does he already, what did he already spend, or what did he already give them so he doesn't have to pay anymore? Well, let's go ahead and put parentheses here. Let's add the two things that he paid right away. Well, he paid the $120, right, as a down payment. He paid for it. And then he also technically paid the $50 because he's going to get that as a discount. So in parentheses here, these are the two things that he doesn't have to pay for anymore because he's already paying for it or he got the discount. Okay. Now, Tyler's mom is going to be giving him half of whatever is left of whatever this is. So we have to figure out what this whole thing is, right? And then we have to divide this by 2 because his mom's going to be paying for half of whatever this is. So if we can go ahead and answer this question, we're going to be able to figure out what Tyler still owes here, all right? So let's see if this makes sense. If we go ahead and evaluate this thing, let's see how much he's already paid. Let's see, this is going to be, I'm going to turn this into parentheses here. So it'd be 800 minus 170 is basically what he's already paid, all right? The discount and whatever he paid initially. Now let's see how much money is left after he's paid that 170. Well, 800 minus 170 is going to be $630 left, but then his mom's going to pay for half of that, all right? So if you go ahead and take that 630 and cut it in half, how much does Tyler still owe? Well, half of 630 is going to be 315. So if you needed to do any work on the side or calculations, feel free to do so. Well, hopefully this makes sense. What's our conclusion going to be? We can go ahead and say that Tyler still owes $315 on this computer. Let's check out number 6. For number 6, Wally is buying a game for $54. He's going to put $20 down because that's what he has for the game right now, but he also has a coupon for $7 off, so he's basically taking care of the $20 and the $7 right away. Wally's parents are going to be covering 2/3 of whatever the balance is after he pays that 20 and that 7 as a birthday gift. The question is how much does Wally still have to pay for that game, or what does he still owe? All right, let's think about this for a moment. But the original game here, right, it's going to be 54 minus what has he already paid? Well, he's already technically covered the $20 and then the 7 for the coupon. So those two things added together will let us know how much he's already taken care of. Now, this whole thing, if you subtract the 20 plus 7 from the 54, that's going to be what is left, or what is the balance. So if we go ahead and take this whole thing and multiply this by 2/3, that's going to tell us what Wally's parents are covering, right? Now think about this. If Wally's parents are covering 2/3 of it, what is Wally going to be covering afterwards? There's still going to be what left over there. Now, if 2/3 is what Wally's parents are going to be covering of the entire amount, what if we want to find what Wally's paying? Now, if they're paying 2/3, Wally must be paying for 1/3 of whatever that remaining amount is, right? So if we go ahead and evaluate this expression here, this will tell us what we get in terms of what Wally's going to owe. Now, if you want to keep this 1 as a 2 and keep it as 2/3, that's perfectly fine if you want to find out what Wally's parents are going to be paying for this game here, right? But it depends on what you're looking for. We're looking for what Wally's paying. So if his parents are paying 2/3 of the balance, Wally must still owe 1/3 of that balance, okay? Let's go ahead and evaluate this thing. Let's go ahead and start with the inside grouping symbol here. So 20 plus 7 is going to be 27. So I'm going to go ahead and keep the parentheses. I'm going to change the brackets to parentheses. So 54 minus 27. Again, that 27 is really what Wally's taking care of in the beginning, that $20 plus the coupon. Let's see, after the coupon and what he paid, let's go ahead and subtract to figure out. If you go ahead and take this 27 and multiply it by 1/3, again, Wally's covering 1/3 of this because his parents are covering 2/3. If you go ahead and take 1/3 of 27, that's just going to be equal to 9. It's the same thing as 27 divided by 3. So this is going to be 9. And again, if you wanted to be finding out what Wally's parents are covering, you can go ahead and take the 27, the remaining balance, take away 9, what Wally's paying, that's going to be 18. Or that's the same thing as 2/3 of 27. And so we just found out that Wally still owes $9 on this game. All right, let's check out number 7. In this example, Samantha bought a new TV for $580. She put $140 down, so she paid that right away. And then she had a coupon to save $40, so that's going to be subtracted off the cost as well. Samantha's adult or parent here is going to be covering 3/5 of whatever the balance is going to be as a birthday gift. So the question is, how much does Samantha still owe on this TV? Now, this is very similar to the last one, so if you want to try this on your own, feel free to do so. Otherwise, let's go over it together here. So $580 is the total of this TV, the cost of it, right? Now, let's subtract what she's already taken care of, or Samantha's already paid for the $140 plus the $40 coupon. So those two things added together are subtracted from the cost because they've already been taken care of. Now, if you want to go ahead and see what we're going to multiply this by, Samantha's adults are going to be covering 3/5 of whatever is left here. So what does that mean Samantha still has to cover? That means Samantha still has to cover 2/5 of whatever that cost is going to be. So again, this entire thing tells us what still needs to be paid, and Samantha is going to be covering 2/5 of it since her adult is going to be covering 3/5 of it. Okay, so that makes sense hopefully, because 2/5 plus 3/5 equals 1/2, or the rest of the cost. So let's go ahead and evaluate this thing. So let's go ahead and add 140 plus 40. If we go ahead and do that, that means that this 580 and this, we're subtracting 280 here. 280 was already taken care of. And then we'll take 2/5 of that afterwards. So 580 minus 280. Let's see, the TV was 580, but 280 is already taken care of, so we're looking at 300 is left. And let's see, if Samantha's going to be paying 2/5 of it, let's go ahead and do that. So if we go ahead and look at this 300 times 2/5, well, that's basically, if we can say 1/5 of 300 is 60, then 2/5 would be 120. So if you go ahead and multiply this, it's going to be 120. And so Samantha is still going to owe $120 on this TV at this point. All right, let's check out number 8. Here, Adeline bought a new cell phone for $1,100. Okay, Adeline put $370 down, which she pays right away basically, and then got a student discount for $90. So that's taken care of as well. Adeline's parent gave Adeline 3/4 of the remaining balance as a birthday gift. How much does Adeline still owe for this cell phone? Sorry, I spelled this wrong a little bit. All right, so let's go ahead and set this up. We have 1,100 here. 1,100 is the total cost of the phone, minus what's taken care of. Well, the 370 as well as the 90 are both taken care of. Let's add those two together. Then this entire thing would be what's left on this cost of the cell phone. So what does Adeline still owe on this phone? Well, if her parents are covering 3/4 of the balance, that means she still has to cover 1/4 of the balance here. So you can go ahead and put 1/4 right next to it, or you may be used to more seeing a multiplication next to it, and that's fine too. So let's go ahead and do this. Let's go ahead and take care of what's already paid for or taken care of here. So we have the 1,100, the total cost of the phone, minus this is before 160. That part is taken care of. And then 1/4 of it is what Adeline's going to have to pay herself. So at the end here, we're going to see this 1,100 minus the 460. If we take 1,100 minus the 460, we know that $640 are still needing to be paid for this phone. And if we go ahead and multiply this by 1/4, that's going to be what Adeline still has to pay. Now, if you go ahead and take 1/4 of 640, basically that's 640 divided by 4, that's going to be 160. Adeline still owes $160 on this phone. All right, so there you have 8 different examples of where we went ahead and practiced applying our understanding of evaluating numerical expressions to a couple of different contexts and applications. So hopefully you can kind of like put some more thought around where you can maybe use this in different parts and thinking about how to apply it in different ways. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.